This video will show you how to define element properties using Patran 2010. I'll be using this model in Patran to show you how to create 1D, 2D, and 3D finite element properties using Patran. So I'll begin by defining the properties for my 1D elements that are along this meshed curve here on the bottom. So from the Properties tab, under 1D Properties, I want to define beam properties for those elements. So my action, object, and type are create 1D beam. And I'll go ahead and give this property set a name. I can then click Input Properties, and I need to select my material that will be applied to these elements. Now I can click on the material icon and see that I already have an existing material defined in my database. If I didn't, I would need to go back and define my material properties first before I can then apply them to the element properties. So I've selected my material. The next thing I do is I'm going to define the section, the cross section that I want to apply along this 1D beam. So I can choose from a variety of different shapes here, but I can see that there's an I-beam, and that's the section that I want. So I'll give it a name, and then define my height and width and thickness values to represent my beam section. In this case, I have a height and width of 1, and all of my thicknesses are 0.25. Once I entered the appropriate values, I can then click Calculate and Display to have Patran draw the section for me. This is the cross section as it will be applied to those 1D elements. So I can look at this and make sure that the dimensions are right, and I can see that they are. It's 1 unit high, 1 unit wide, with a 1/4 inch thickness. But also, looking at this, the element themselves will be like coming out of the screen. So this section will always be applied normal to my elements. But what I still need to define is how it will be placed rotationally. So I can look at this and see that the way this is defined, the web of my beam is vertical. So when I apply this section to my elements, I want to keep an orientation that I need to properly align my web. And that'll be our next step. So I can click OK. And now I need to define a bar orientation vector. So as I apply that I cross section that I defined along my 1D elements here, I want it to be oriented the same way as these other I-beams. Again, with the web oriented along the global Y direction, or lying in the XY plane. So for my bar orientation, I'm going to enter 0, 1, 0. And this will define that XY plane when used with the X direction, which the element lies in. So the one orientation vector that I couldn't use would be along the element direction, which in this case is along our global X. So with my orientation in the Y direction, I can go ahead and click OK. Now I need to select my application region. So which elements in my model will this property be applied to? And I'll apply it to all of the elements on that curve. I'll click Add, OK, and now I can apply and create my 1D beam elements. Now if I want to view these element properties and see that they've actually been applied the way that I intended, I can go to Display, Load BC Element Props, and scroll down and select a 3D beam display. So I can click Apply, and now I can see how those element properties are being rendered on my finite elements. So what we've done here is we've used the element properties and applying a constant cross-section to make up for the geometry information, or the spatial extent, that was missing from the element themselves. And I can rotate the model and see that I did in fact get that beam orientation correct. If I'd used a different orientation vector, like say 1 unit in the z, this would be turned 90 degrees on its side and would obviously provide different behavior. So that's how you define your 1D element properties. Now I want to define the properties for the 2D elements of my model. So for 2D properties, I want to define my shell. So I'll create a 2D shell. I'll give this property set a name, and again click Input Properties. Now here I don't have to worry about the orientation because all of my surfaces already provide that information. All of these elements already have a direction. They just need a thickness applied to them. So I need to tell it what material to apply to these elements, and again it'll be our aluminum. And then also what thickness to apply, as currently these elements have no thickness. So my thickness value will be 0.25. Now I can click OK and select my application region, and in this case I'm going to select all of the surfaces that form this 2D I-beam model. I can add, OK, and apply. And so now I've created my 2D element properties that define the thickness and material for all of these 2D finite elements. So now, finally, I'm ready to define properties for my 3D finite elements in my model. So under 3D properties, I'll select solid, and this will create a 3D solid. I'll give this property set a name and input its properties. Now the only required property for solid elements, because remember they already represent the entire spatial extent of our model, is what material to apply to them. So in this case I will again select our aluminum material, click OK, and then select my application region, which in this case will be my entire solid. I can add, OK, and apply, and now I've defined my 3D element properties. So as we've seen, the more complex the spatial extent of the element is, like in the case of the 3D elements, the less we have to define through our element properties. But here in this one model, we've shown you how to define your 3D, 2D, and 1D finite element properties. So this should cover most of the situations that you'll run into in your finite element models.